Question 5, we want to complete the parts from A through D, and the first question is to determine the hypothesis testing H0 and H1. So before starting here, we might want to highlight some information. So the first part that you want to pay attention to, that we are using this model to predict the wine quality measured on the scale from 0 to 10, and we are based on the alcohol content percentage and the amount of chloride added. All right, now they give us two more information. The SSR is going to be 20,899 and the SSE is going to be 39,229. Okay, so, and I forget to mention as well, the sample size is 35. So now, because we have this is x1 and this is x2, so we expect K is going to be just 2, and this is going to be the number here. So this is the table from your book, all right? Since n equals to 35, so n minus 1 is going to be at 34, and 35 minus 2 minus 1 is going to be at 32. So far we get the degree of freedom done. Now the SSR is given to us, so this is going to be 20,899, and the SSE is going to be 39,229. By the way, we could plug them into Excel and generate the whole table, but I'm going to do it by hand here. So the SS total is going to be the sum of the SSR, so this is the formula. It's going to be SSR plus the SSE, so it's going to be equals to 20,899 plus the 39,229. And just you can plug it into the calculator. All right, so going back to the question, we see the hypothesis testing. Since we knew already K is going to be 2, so the H0 would be just beta 1 equals to beta 2 equals 0, and the H1 it would be at least one of beta j different than 0, and you stop at 2. All right, you don't want to continue all the way. All right, and again, beta 0 means there is no slope. All the slopes are 0, and the line is going to be horizontal, so there is no linear relationship. And H1, it means at least one of the slopes is not horizontal. That means there is different than 0, and therefore there is a linear relationship. All right, so H1 is the one that works in our favor. Okay, let's go back to the question. Here H0, we have beta 1 equals beta 2 is going to be 0, and the other one is going to be at least one of the beta j's, 1 or 2. The 0 is not, right? And this is going to be the 1. Check it. Good. All right, so the F statistic right now. Okay, let's go to the Excel. So here I just copied the same values in a table, an Excel table. It can be less painful to do all the variables, right? Okay, so how can I get, my objective again is to get the F stat, and how can I find my way all the way here? So I want to get to the F statistics over here, right? Okay, so I'm going to follow that's the formulas and put them in Excel. So this one, the formula here is the sum square. Let me put it clear. So the formula here, the SST is going to be the SSR plus the SSE. In other words, I'm adding vertically these two numbers. So this is going to be equal sign, sum, open a parentheses, select these two numbers and enter. So it's going to be 60,128. Now, if I want to find the mean square regression, I'm going to divide this number by its degree of freedom. So I'm going to divide the SSR, this one, by K, which is 2. All right. And this is really easy on Excel. You're going to put equal sign. You're going to click on the SSR, this value, divide by 2, and enter. All right. So I'm going to do a similar operation right now with the MSE. We're going to be the SSE, which is sum square error, and divide by degree of freedom, which is 32, this number, right? And again, I'm gonna put equal sign, equals, click on SS error, and divide by degree of freedom, which is 32, enter. Okay, now the F value is gonna be the two values we just found, which is the mean square regression and mean square error, divide them by each other. All right, and that's going to be your F stat. So you're going to be equal sign. I'm going to click on the number on the top, divide by the number on the bottom. That's all. Okay, you get it. So copy it and go back to the problem and paste it. Now they want to round it to 2 decimal places, so 523. That's going to be 52. Check it. All right, good. Now we are looking for the p-value, and we found the p-value in previous examples. So this is going to be equal sign, and what I'm going to use here, I'm going to use the F distribution. So F dot distribution, and I'm going to use the right tail one, right? So the right tail requires you to input the X. The X is nothing else than F stat, this value here. And then degree of freedom is going to be 2, or regression, comma, and then degree of freedom of the error, which is 32, and close the parentheses and enter. So this is going to be your p-value. Again, copy it and paste it. And then you want to round to 3 decimal places, so that's going to be 0.001. Okay, good. Now the p-value, what we're going to do is we're going to decide accordingly with the p-value whether we accept or reject. Again, the formula for the p-value is, so if I have the p-value less than the alpha, and this is true, then reject A0. Rejecting A0 means there is a regression line, and we have enough evidence. Of course, the evidence to reject, right? Okay, so we just have to compare them. So the alpha we know is 0.001, and the alpha value, let me go back to the problem. The alpha value is right here, the level of significance 0.05. So is it true that 0.001 is less than 0.05? This is true. So if it is true, we're done. We are rejecting A0. All right. Okay, let's go back. The p-value is smaller or less than the level of significance. Is good. And we do reject the null hypothesis, and there is sufficient evidence to do this. Great. All right, so for question B, we want to find out which one of them is the right statement, and this is the interpretation of the p-value. So before going there, I'm just going to go and explain again what is the p-value. So this value here where we stop, this is what we call the F critical or F alpha, is where separate the area of the alpha value. So this is my alpha value in here. All right, and this one 0.05. Now where the alpha stop, you're gonna separate our chart in 2 zones, the rejection zone So reject here 80, and from this side do not reject 80. Okay, so now we wanna as well figure out where the regression is gonna happen, right? So if you reject 80, there is a regression. All right, so this is yes for regression, and this is no regression. So then if you do not reject 80, you don't have regression. Now the statement that you have over there, they are most of them talking about no linear relationship. So no linear relationship, it means no regression. So the F stat therefore has to fall somewhere here. So now reading the statement, the p-value is the probability of getting an overall test statistic. So the overall test statistics, this is overall, that's the F alpha, and less than the sample result. The sample result, that's going to be the F stat relating to our example. So here we can see it on the chart. If the F alpha is greater, all right, then we have no regression. So what we are looking for, F alpha greater than F stat. So this implies do not reject, and this implies no regression. No regression means no relationship, no linear relationship. So that's what we are looking for, and this is obviously of getting an overall F alpha equal or less. This is absolutely not what we are looking for, so it might be a different one, right? So let's go back. It should be greater. All right, let's go to our problem, and a similar one to this I think is D. The P is the probability of getting an overall test statistic equals or greater than the sample result. And let's check it, and good. All right, question C, we were looking for the coefficient of determination, R squared, and then we want to make interpretation of its meaning. So this is the definition of R squared. So it is the sum square regression divided by sum square total. All right, and we do have all the values in the table. So here is the sum square regression, 20,899, and sum square total is going to be 60,128. So we can just plug it in Excel. So it's going to be equal sign of 20,899 and divide by 60,128, and that's going to be the number. Copy it and paste it, and you want to round to 4 decimal places. So it's going to be 0.34757, so that's going to be 6. Check it, we're good. So the interpretation of this, you're going to be turn it into a percentage. That is 34.78, and of the variation of the dependent variable. So the dependent variable is the quality here. Wine quality can be explained by the variation of the independent variable, and the independent variable, there are 2 of them: alcohol percentage and chloride, and this is it. It seems that I typed 78 instead of 76, so 76 here, and the rest is still the same. Question D, we want to look for R squared adjusted, and here we can just apply the formula as it is. So the R squared adjusted here, it can be 1 minus parentheses, another parenthesis, 1 minus R squared. So R squared being 0.3476, 0.3476, close the parentheses. So the n minus 1, we can get it from the Excel spreadsheet. So here the n-1 is going to be at 34. This is n-1, and this is going to be n minus k minus 1, which is 32. So it's going to be 34 over 32. And for this one, we can use just a calculator. Okay, so we're going to plug it in. 1 minus, open parentheses twice, it can be 1 minus 0.3476, load the parentheses once, and this is times 34 divided by 32, and then exit and close the parentheses. So it's going to be 0.3068, and that was going to be a smaller value, right? So the r squared adjusted is always smaller than the r squared. Okay, we rounded to 4 decimal places, and that should be it. Check. Good.